Oh, it should be log, sorry. Log. That's supposed to be log, sorry.
There were two of them, so three of them.
There's three of them, sorry. It's log. Make all those lobes logs. BG, I don't know. All right. So you remember that the answers to logs are always the exponents, right? And when our bases are the same, 3 to the second and 3 to the third. So if our bases are the same, what do we always do with the exponents? That's what we're doing. We're doing it in logarithmic form. When the bases are the same, our exponents get added. And how do we write it an exponent? We write it as a log. When we divide, what are we doing with our exponents?
Subtract.
Yep.
Smaller one from the bigger one, right?
The denominator from the numerator. When we raise a power to a power, what do we do with those values? We multiply them. I'm just showing you what those rules are. Pooja, you awake? Yeah. Good.
How did that one happen? That's last.
Because isn't it the power times the other power?
Yeah.
That's all I'm doing.
Why are they next to it?
Well, it's got to come out in front of the log. It's not going to be part of the log anymore. It's going to come out in front of it.
Wait, I actually don't understand that. Sorry. I might have serial problem. So the n would be.
Aren't I multiplying?
Yeah.
That's all I'm doing. Remember, the log of m is an exponent. It's really an exponent, right? All right, here we go. We're just applying these. So if I'm multiplying two parts in a log, if I want to expand it out, I'm going to add the individual logs. Okay? If I am dividing two parts in a log and I want to expand it out, I'm going to subtract the two parts. If in my log I'm raising something to an exponent and I want to expand it out, I'm going to take that exponent and multiply it by the log. That's all I'm doing. Ellen?
Like log n, are you saying that's like one log?
Mm-hmm. One log.
Wait,
Pooja?
that last one.
If I give you 2x to the x raised to the second, I'm multiplying those values. I'm multiplying the exponent parts. I'm multiplying the exponent parts. We know that log of m represents an exponent, right? If I said log of m is equal to, isn't it an exponent? This is just, so I'm taking the n, timesing it by the other exponent. Why don't you just watch? Why don't we watch? Okay, let's do something. All right, I'm taking the log of b of 5/8. So if I am dividing and I want to expand this out, I'm going to take the log base b of minus the log base b of 8. Look, if I am dividing and I need to expand it out, I take the numerator minus the denominator's log. Got it? What is the log of 5 defined to be?
Why are we saying log b?
It's a base. It's just who cares what the base is? Okay? 0.898 minus 1.161. What is that? I'm giving them. I'm giving them. It helps if you have these notes printed out.
Yeah, it's right in front of you.
Okay? So 0.898 minus 1.161 is what? Negative 0.266? Okay. Yep. You'll be given some, yeah. Okay? Now, I don't know what 40 is, right? How do I use 5 and 8 to get to 40? So that's really log base b of 8 times 5. Agreed? And if I am multiplying in a log statement and I want to expand it out, my rule tells me what do I do with those individual parts. So this is log base b of 8 plus log base b of 5. But we know that log base b of 8 is what? 1.161, and log base b of 5 is 0.898, and I add those together, and what do I get? 2.059. It is not a log because we're adding them together. We know what these values are. But if we're multiplying, when we expand it out, we add. If we're multiplying our bases, we are adding those exponents. Okay, log base b of 64. It can be 8 times 8. It can also be 8 squared. And this one would be log base b of 8 plus base b of 8. This one would be what? When you raise a number to a power, you multiply. So that's going to be 2 times log base b of 8. Right? Isn't 64 8 squared? And look up here. If it's squared, if there's a power, that n, whatever that exponent is, comes out front. That's the rule right here, and we multiply it by the log of whatever is in here. So 8 squared, that means this 2 comes out front, and this 2 comes out front, and I'm just left with log 8 left over here. In either case, you're going to get the same answer. What is it? 2 point who? I mean, sometimes, yes. Okay. 125. If all of I have are 8s and 5s, then how do I get 125? 5 cubed. Log base b of 5 cubed. Expand it out. 3 log base b of, and what is log base b of 5? Is it 0.898? And what is that?
It is 2.6.
Making some sense? Sort of? Sort of?
Yes.
Okay. Next page. Yeah, so all we're doing now is just expanding without numbers. We have no numbers, we just have variables. Following the same rules. This is log base 6 of 5x cubed divided by y. We're expanding, expanding, expanding. There can be one thing next to that log, but each time we expand, we, I don't know what I was going to say. We write the log with that expansion. That's what it was. Okay, so let's just break up the numerator and the denominator. What am I going to do? I'll say log base 6 of minus. Okay. Right? To divide means to minus. Right? I can't have a bunch of stuff next to my log statement, and I got way too much going on in that first term. I got multiplication going on. So expand out the multiplication. This part now says log base 6 of
3, 5x.
Oh, hold on. No. 5. Because the 3 is only on the x. And then what do I do to separate these? What does to multiply mean expanded? Add. Log base 6 of x cubed. And then minus log base 6 of y. We're going to just bring that down. Now, I can't have this. I got to rewrite this. Where does this 3 go? In front of where? Just. So log base 6 of 5 plus 3 log base 6 of x minus log base 6 of, and that is fully expanded. Uh-huh. And it doesn't matter the order that you have. What matters is the signs. So these two can flip-flop in order. Does that make sense? It really doesn't matter which one of these. This one must have the negative sign with it. So this one could go first as long as it's negative. Negative means it goes in the denominator. Okay? This is a square root symbol here. I'm going to go down. So, do I have any division?
Yes.
Do I have any division? No. But I have a square root, right? Over the entire thing. That means, well, how do you rewrite a square root as an exponent? How do you rewrite the square root symbol?
Oh,
1/2. Isn't this log base 2 of 2x plus 2x to the 1/2? Square root. I got rid of the square root and wrote it as an exponent. Oh, I just dropped it. Sorry. So what's that 1/2 going to go? No, you can't just square root the whole thing. You can't square the whole thing. It's going to go in front. Exponents go out in front of the log statement. Now, I want this whole expanded form to have that 1/2 because all of it's under the square root. So I'm going to open up a set of parentheses because I want that 1/2 to go with the whole answer. So I'm going to go log base 2 of 2 plus,
log base 2 of x cubed.
but that 3 can really come out front and go 3 log base 2 of x. Yeah, because there's only one little thing going on. You can distribute the 1/2. And I would have 1/2 log base 2 of 2 plus 3/2 log base 2 of x.
Okay, I had that.
No, but if you like to see it.
Either way, okay?
Shh, Abby, Polly. So to multiply means to add, and an exponent means it comes out front.
So how is log?
Because every time you separate it, you tell me you're dealing with a log.
So you add a log.
I'm not adding, but I need to tell you, remember, if I'm multiplying, each one's got to have the log with it. Let's go the other way. Where is this 3 really going to go? This 3 represents a what? ln4 plus ln3 cubed, yes? Minus ln of 12. Yes, and I will, but I didn't want to do too much. I don't know that. Okay. To add means to do what? Multiply. So when I put these, I want one ln statement. I don't want 3 because I'm condensing.
So ln
4 times 3 to the third, and the minus means divided by 12. 1 ln. I don't see ln over ln. It's 1 ln. I'm condensing it to one statement. So that's ln of 4 times 27 over 12, which is what?
9.
This is all the ln of 9. So you got to think forwards and backwards. Expanding, then I do what? Show multiplication means I add. To show division means I. Okay? And so then the other flip way is just going in reverse. If I see multiplication, I'm going to do what with those? I'm sorry. If I see addition, I'm going to do what with the bases? Multiply. If I see subtraction, that value goes in the denominator.
Will you explain how you went from minus ln 12 to divided by 12?
I'm going to have one ln statement for this whole thing. These two get multiplied. This thing, because it's being subtracted, has to drop down to the bottom. Look at this one. I'm going to write one log base 7 statement. Do I have a fraction? Do I?
Yes.
I'm showing minus, right? That means I got a fraction. Not multiple fractions, one fraction. What goes up top? Log base 7 goes out front. What goes on top of my numerator? 3 and
2x.
X squared. Because that 2 is really the exponent. What goes down? You have 2 log base 7 of x. Because this is minus, it goes below.
When you divide by that and then divide by that.
And so if you're dividing by dividing, aren't you dividing and then we're flipping it? It's still going to end up in the bottom, Ellen. The rest of these examples are already downloaded on Moodle. All right, so if you just want to look at the notes without the voice.